Welcome to another episode of Drops of Science, the multilingual podcast that brings you the latest updates and discoveries in natural sciences. In the first news, we explore how human activity is disrupting the balance between plants and insects, an interaction that has persisted for millions of years and has driven the joint evolution of chemical defenses in plants and adaptation strategies in insects. A recent study by Drs. Zhang and Bochum from the University of Michigan investigated the effects of glyphosate, a widely used herbicide, as a potential selection agent capable of altering these ecoevolutionary dynamics, with far-reaching implications for ecosystems. The study focused on Ipomea purpurea, a common weed, by analyzing two experimental groups, one treated with glyphosate and one left untreated as a control. After applying the herbicide, the researchers assessed the damage caused by herbivorous insects and measured the plant's survival as an indicator of fitness, essentially their ability to thrive in their environment. The results were surprising. Plants treated with glyphosate were significantly more vulnerable to herbivores compared to the control group. In other words, plants weakened by the herbicide were more likely to be attacked by predators. The researchers hypothesized that glyphosate interferes with the shikimate pathway, a key metabolic process that enables plants to synthesize chemical compounds used for defense against insects. When this mechanism is disrupted, plants become less capable of resisting various types of attacks. Another noteworthy finding was that plants resistant to glyphosate were not only protected from the herbicide, but also more resistant to insect herbivores. These results, unexpected according to ecological theory, suggest that the genetic mechanism underlying herbicide resistance may interact with those responsible for insect resistance, possibly through a shared genetic basis or epigenetic phenomena. Epigenetic phenomena influence how genes function without altering the DNA sequence itself, acting like switches that turn specific processes on or off. Furthermore, resistant plants tended to produce more seeds than sensitive ones, providing them with an evolutionary advantage that could allow them to dominate future plant populations. This suggests that these plants, in addition to surviving better, are more effective at passing their genes on to subsequent generations. The study's findings highlight how glyphosate, a human-introduced herbicide, can significantly disrupt the ecoevolutionary dynamics between plants and herbivores. Glyphosate not only reduces the effectiveness of chemical defenses in sensitive plants, but also encourages the selection of greater resistance to both herbicides and herbivores. This dynamic could upset the long-standing coevolution between the two groups, causing plants to fortify their defenses while insects fail to evolve in tandem. Herbivores may adapt their behavior, preferring less resistant plants, thereby altering the composition of insect communities. Disrupting plant-insect interactions is not only an ecological concern, but also poses cascading consequences across other levels of the food web. Intensive agriculture and the widespread use of herbicides such as glyphosate affect not only crops but also the surrounding environment, modifying evolutionary processes that took millions of years to develop. This study serves as a wake-up call, emphasizing that human activities, often designed to address immediate challenges, can have long-term and unpredictable impacts. It underscores the importance of continued research into these dynamics to understand and mitigate their effects, while promoting more sustainable management practices that respect the natural balance. We continue talking about plants, but shifting our focus to the Amazon, where a team of researchers from various Brazilian institutes, spanning from Belém to Pará, studied the impact of climate change on a vital botanical family, the Chiperaceae. This family encompasses over 5,000 species, primarily found in tropical regions, thriving in both terrestrial and aquatic habitats. Chiperaceae are crucial for ecosystem balance. They control eutrophication, reduce sedimentation in rivers, and contribute to water purification. Additionally, they are popular as ornamental plants in aquariums due to their ability to create microhabitats. However, climate change and expanding human activities are rapidly transforming the habitats these plants rely on. The removal of riparian vegetation, for instance, increases sedimentation in waterways while lowering water quality through reduced pH and dissolved oxygen levels. To evaluate the potential impact of climate change on this family, researchers selected 12 species based on their spatial distribution in the Amazon and the availability of observational data. They categorized these species into 3 habitat-based groups: aquatic, amphibious, and terrestrial. To model the effects of climate change, the researchers used the Global Climate Model SSP-585, a scenario predicting significant increases in greenhouse gas emissions and severe climatic changes in the future. Using species distribution models, they analyzed the relationships between bioclimatic factors such as average annual temperature and rainfall seasonality, and the plant's geographic ranges. They also examined whether protected areas in the Amazon could provide refuge for these species amid climate challenges. The results were concerning, even though most species are currently relatively widespread. Habitat loss is projected to reach up to 43% for aquatic species like Scleria amazonica, while terrestrial species such as Cyperus reflexus could lose as much as 93% of their suitable areas. Average annual temperature was found to benefit aquatic and terrestrial species, but negatively impacted amphibious ones. Conversely, rainfall seasonality could favor amphibious species, though extreme floods and drought pose a threat to all groups. Even if these findings are alarming, protected areas offered a glimmer of hope. Many species analyzed currently find refuge in these zones, and projections suggest these areas will remain critical for the survival of Cyperaceae in the future. However, researchers emphasize the urgent need to expand both the size and effectiveness of these protected areas. While these measures are vital, they will not suffice on their own. A concerted global effort is necessary to safeguard the Amazon's ecosystems and prevent potentially irreversible changes. The next story takes us to the cold Alps, where ski resorts are threatening climate refuges, areas that currently and in the future provide suitable conditions for the survival of species vulnerable to climate change. These refuges are vital for biodiversity conservation, as they ensure stable habitats in the middle of rapid environmental transformations. These refuges are often located near ski resorts in the Alps. However, as temperatures rise, the pressure of these habitats could increase, with ski resorts likely moving to higher altitudes to remain operational. A group of Italian researchers, led by Dr. Roseo, analyzed this potential conflict by assessing both the impact of existing ski resorts and the possible effect of new infrastructure in the future. They used computational modeling to overlay maps of climate refuges for some alpine bird species with those of ski slopes, including a 1-kilometer buffer zone around the slopes. This method considered the ski slopes and related disturbances, such as slope grooming, infrastructure development, land management, and off-piste skiing. Additionally, the researchers modeled the potential distribution of ski slopes under current conditions and future scenarios, incorporating factors such as slope gradient, solar radiation, mean annual temperature, and precipitation. At present, ski slopes in the Alps cover almost 500,000 hectares, with the average altitude of ski resorts around 1,792 meters above sea level, closely aligning with areas deemed suitable for biodiversity refuges. Alarmingly, climate refuges, which are crucial for many species, overlap with ski slopes by a total of 160,739 hectares. This means 57% of the climate refuge area falls within zones currently suitable for ski facilities, highlighting the significant impact ski infrastructure could have on these vital habitats. Projections for the period 2041-2070 indicate a troubling increase in this overlap, potentially reaching 69–72% depending on the climate model used. In absolute terms, this would mean an additional 17,000 to 21,000 hectares of overlap, an increase of 21-25 compared to current levels. These findings underscore the urgent need for strategies to mitigate the impact of ski resorts on climate refugees. It is critical to factor in the spatial distribution of these areas during planning processes, striking a balance between socioeconomic goals and the imperative to protect biodiversity. This is especially pressing as many climate refugees lie outside protected areas and therefore lack formal safeguards. Public bodies, often working in collaboration with private companies, plays a pivotal role in planning and approving new construction projects. By recognizing the ecological importance of climate refugees, policymakers could help preserve alpine biodiversity while also ensuring that the future of winter sports is more sustainable. Let's now turn to an iconic inhabitant of the Caribbean waters, the Florida manatee, or Trichechus manatus latirostris, one of two subspecies of the Caribbean manatee. A recent study by Drs. Plukan and Tullman has shed light on the chronological origin and expansion of the Florida manatee, revealing crucial details for the conservation of this species. Until now, little was known about the presence of these animals before the 50s, and research rarely focused on pre-modern populations. However, understanding the history of the manatee is vital for planning effective and sustainable conservation actions. The researchers gathered both systematic and opportunistic data from archaeological and historical records, analyzing manatee remains from pre-colonial sites and archival reports of sightings, dividing the results into 4 historical periods. During the pre-colonial period, spanning 12,000 before Christ to 1513 Anno Domini, there is no definitive archaeological evidence of manatees in Florida. Although manatee bones have been found, they were often fossils repurposed as tools with no indications of active hunting. When European explorers arrived, they referred to sea cows or sea wolves, ambiguous terms that could also describe seals or whales. The first confirmed sighting occurred in the 18th century. In 1774, a manatee skeleton was described in detail. By the 19th century, manatees had become relatively common in southern Florida, with their meat and skin extensively hunted and traded, particularly to Cuba. But even at this time, their distribution was limited, with few reports from the Gulf Coast. By the late 19th century, manatees were becoming more common along the southern and central Atlantic coast, with occasional sighting in Tampa Bay and Charlotte Harbor. In 1892, a state law was passed to protect manatees, which were already considered at risk of extinction. By the 50s, manatees emerged as both a tourist attraction and a symbol of Florida, representing the state's aquatic ecosystem. Yet, what archaeological and historical evidence reveals is fascinating. Manatees have never been as common or widespread as they are today. This challenges the assumption that their population was naturally much larger in the past and that their decline is a recent phenomenon. Instead, the modern expansion of manatee populations is largely attributed to human and environmental factors, such as the creation of artificial thermal refuges, the construction of canals, and the enforcement of hunting bans. This study not only corrects an inaccurate historical narrative, but also provides a clear understanding of the factors driving the expansion and contraction of manatees populations. Grasping these dynamics is critical for setting realistic conservation goals, especially in an era of climate change and increasing human pressures. It is a key step toward planning a better future for this species and ecosystems that depend on it. We conclude today's news by exploring the world of adult play, a social behavior once thought to be unique to humans. A recent discovery involving chimpanzees has overturned this belief. Physical and social play often includes actions that, at first glance, may seem aggressive, such as biting, slapping, and chasing, but are significantly toned down in playful context. This type of behavior indicates a high level of trust between participants and was traditionally believed to be exclusive to juveniles. Yet, much like humans, some chimpanzees continue to play well into adulthood. This finding comes from a study led by Dr. Samuni and colleagues, who observed 57 adult chimpanzees in Côte d'Ivoire over 6 years, recording nearly 5,000 social play sessions. These sessions included a variety of activities, from wrestling and tickling to chasing, swinging, and simulated biting or tugging. Some games even involved objects like logs, fruits, shells, sand, and water. The research also shed light on when and why play among adult chimpanzees occurs and its significance for group dynamics. For instance, adult males were more likely to play with individuals with whom they had recently argued, suggesting that play may act as a mechanism to regulate and repair social bonds, reducing tension. Additionally, males often chose to play with those they shared strong affiliative ties with, likely because these relationships were grounded in mutual trust and familiarity. Interestingly, play was especially frequent before critical collaborative activities, such as territory defense or group hunting. Chimps that engaged in play together were more likely to cooperate effectively in these collective efforts, demonstrating how social play strengthened group cohesion and collaboration. Adult females showed a different pattern, playing more frequently on days when another female in the group was in heat, a situation that typically heightens aggression and tension within the group. In such cases, play seemed to act as a stress relief mechanism, helping to maintain social stability. Adult play in chimpanzees is far more than a simple pastime. It is a sophisticated behavior that demands communication, synchronization, and quick reactions to others' cues, skills that closely resemble the coordination required for collective actions. Moreover, the intense physical contact during play, often mimicking aggressive interactions, likely enhances trust between participants. This research opens up new perspective on the study of social behavior in chimpanzees and other species, emphasizing the enduring importance of play, even in adulthood. Beyond fostering social bonds, play has a crucial role in reducing tension and promoting cooperation, ultimately benefiting the entire group. This concludes today's episode of Drops of Science. Thanks for staying with us. See you soon, and good science!